Okay, so a couple other things that we need to mention about our different types of logarithms before we continue. The two kind of special case scenarios we have is common logs and natural log. So our common logarithm is simply a logarithm of the base 10. So if it has a base 10, we call it a common log, and we actually don't write that base 10 in there. So if you ever see a logarithm which just says log of something, it's an understood base 10 because it's a common logarithm. Okay, then our natural logs are where we have an inverse of an exponential, a natural exponential function. So that's in our calculator, or that we talked about in the other video as Euler's number, which is that little e. So if we have a base of that little e, we don't write it as log base e, we write it as ln. Now I've had students in the past write this down, this is lowercase ln. So people in the past have been confused thinking that's an I or a 1. So again, just my poor handwriting, that's an L. So log, natural, I don't know why it's not NL, it's just, we'll go with it. ln of x is log base e. Okay, so like I said, that natural log is the inverse of this guy, where we have that Euler's number to the x. So if you look in your calculator, you should see that, that e, and again, we'll have talked about that in the exponents video. All right, so if we are converting then to logarithms, again, if you use your swirl method, we're starting at log base e, picking up that y, ending on the x. So that conversion there would be log base e, which we don't write, we write ln. So ln of y equals x. Okay, so again, when we're talking about our conversions, main thing is if you're going from exponential to logarithms, make sure that your bases are the same and make sure that you're solving again for that exponent, because that's the whole point of what we're doing. All right, so let's go ahead and talk about a couple different properties of logarithms. So what we're going to use to solve logarithms or logarithmic functions is going to be this conversion and then different properties of combining logarithms. So I'm going to write these here and I'm going to try to leave these the rest of the time, that way we can use them as we go along. Okay, so again, we need to be able to, and maybe I should put it this way, whenever we're solving, we kind of have a couple different things we want to be able to do. We want to be able to cancel out via using this conversion, so we want to be able to convert between the two, exponential and logarithmic. That's how we're going to solve a lot of them. And we also need, again, to be able to combine logarithms. Okay, so how we combine is using our rules. So first off, we've got the addition rule. So if we've got log base a of m, and we're adding another logarithm with the same base, so it's just like exponential, they have to have the same base. If we had adding these together, we're going to combine them as a single logarithm with the same base, and then we're going to multiply this m and n. Okay, and then if it's subtraction, I bet you can go ahead and guess what we're going to do there. We're going to combine those as a single logarithm, again, as long as they have the same base, but now we're dividing that m and n. Then our last thing, whenever we have, or I guess our last rule that we're going to use, and whenever we have kind of our simplified form of logarithms, or sometimes we're solving, if we're taking logarithm of an exponential function. So if we have log base a, and let's say, just for this notation's sake, let's say we got an m to the r power. So we're taking the logarithm of an exponential function. Now, we can't cancel out m and a like we talked about before because they're different bases. So we can't just cancel this out and say it's r, but since these are different bases, what we can do here is then take this exponent and bring it out here as a kind of a coefficient to that logarithm. Okay, so that's a good way to simplify, and that rule works both ways. Actually, all these rules work both ways, which we will go both ways, and kind of, but especially this one will go both ways, would make things easier on us. All right, so this is all our properties of logarithms. What I'm going to do pretty much in the next video is just go over a bunch of examples that you'll see in the homework and on the exam.